at least for some of. Okay, let's begin with Kubernetes. We have already learned one container orchestrator tool in the last class, right? Now let's talk about Kubernetes. Kubernetes is again another container orchestrator tool, right? Which can manage the containers. Managing the containers means maintain high availability of them, load balancing of the containers across the cluster, scaling the containers. In Swarm, we can't do auto scaling. That is possible in Kubernetes. And also rolling updates and rollbacks. What is meant by rolling update and rollback? Anyone?
There is
Rolling
any
up.
issue
Yeah.
with the code or anything deployed, right? So if we want to roll back the versions,
Yeah. Suppose like let's say it was a version 1 and if you want to upgrade the version 2 in your application. Means here when we say version 1 to version 2, it's about Docker image. V1 to V2 and then let's say, yeah. So let's say you have different versions of Docker image stored on the hub, right? We have seen like you will be storing different versions of the Docker image. So when you are upgrading this, right? Like let's say we were our first initially V1 of the Docker image is deployed, then later on we have to upgrade. There might be some downtime seen. So how to do this upgrades without zero downtime? Is that possible? Yes, that's possible in Kubernetes. It has got different deployment strategies. So that's possible. Even rollbacks, like let's say you are in V2, you want to roll back to the previous version of the image. That's called rolling back. So rolling update and seamless rollbacks are possible in Kubernetes with the different deployment strategies like blue-green deployment strategy, canary deployment strategy, and so on. We'll be looking into them. So these are all possible and very effectively in Kubernetes, which is for critical prod deployments, right? So let's begin understanding the basic differences between Kubernetes and Swarm, and then we'll start deep dive into Kubernetes. So what are the basic differences between these two? The first difference is very obvious, I believe. Swarm is a Docker product. Commands are just Docker commands. Whereas Kubernetes is initially a product of Google, now managed and maintained by CNCF, Cloud Native Computing Foundation. And yes, it has got a different commands. And that Swarm, you don't need to install separately. You'll just init. Do you remember we did Swarm init? Correct? But Kubernetes, yes, you have to do the setup and setup varies depending on your platform. You could do the setup in on-premise, on cloud. Again, on cloud, it's different on GCP, Azure and all. Only the setup varies. The concepts, commands would remain same. Right? Again, out of all the tools we have learned, yes, it would be a different kind of setup or else a bit complex when compared with other tools. Even the learning curve is steep, like the concepts are advanced, but learning it with a clarity or proper understanding will help you enjoy the tool. And Kubernetes, another thing is Kubernetes can manage containers or else manage containers from any runtime. What does it mean? We have different container runtimes. If you remember, we were talking about this like Docker, you have OCI containers, LXC containers, Creo, different container runtimes. Whereas Swarm can manage only Docker containers. Right? Of course, Docker is so famous, but you still have other container runtimes which are possible, like those containers even can be orchestrated through Kubernetes, whereas Swarm can orchestrate only Docker containers. Right? These are some of the basic differences. And installation we discussed, commands we discussed, and Kubernetes always prefers declarative approach. whereas Swarm goes with imperative approach. Imperative approach means you write commands from the CLI and you run them. That's how it works. But Kubernetes prefers declarative approach. You define your configurations or deployments in a manifest file. Those manifests could be written either in the JSON or YAML. Right? That is the preferred approach in Kubernetes. And what else? Yeah, security wise, the auto scaling features, all of them are possible in Kubernetes. Auto scaling possible. In Swarm also possible, but it's like you need to configure additional scripts and all. That's not how this works. Auto scaling here in Swarm, you can use scaling. Right? And any other differences? Yeah, obviously the architecture is completely different. Here the architecture is simple, right? Whereas Kubernetes architecture is a bit different. We are going to go through this architecture now. Is this much clear? The basic differences and further differences, the actual differences we'll understand once we get the hands-on, once we get into the architecture. Is this much clear for everyone?
Yes.
Okay, so let me share the architectural diagram. Can you all see the architectural diagram?
Yes.
Right. So like we discussed earlier, again here also, you can create the Kubernetes cluster with any number of nodes. So this is one node. Just a second. So this is one node in Kubernetes cluster. Here the cluster is created with the two nodes, which are called as worker nodes. And there will be one node which acts as a master node. This is called master node. Like you have manager in Swarm, this is called master. This is the master node in the cluster, and the others are called worker nodes, right? And the master node is also called as control plane of the entire cluster, where all the decisions or all the management of the cluster would be taken care by. First, let's go to the worker node. And if you see again, each worker node have got different components. So let us first get into the worker node and discuss those different components. First one is the Docker runtime. Second one is kubelet. Third one is kube-proxy. Fourth one is pod. So these are the four components which works or which exists in every worker node. Let us talk about these components one by one. First, let's talk about the Docker. Docker is the container runtime, right? So if you want to run Docker containers, you need a Docker runtime, right? Obviously, Docker should be installed and running on every worker node. If you see here, you have Docker on every node. This is the container runtime. Like I just mentioned, if you want to run other containers like from different runtimes like OCI and all, that should be installed. So the respective container runtime should be installed. That's the first component. Second component is kubelet. Kubelet is like, see, you will be configuring these agents. We have to configure and install and make this setup. Once we set up, these are the components that would be available on the worker node and on the master node. So again, coming back to the worker node. So kubelet, if you look into the kubelet is the Kubernetes agent running on every node. Kubernetes agent running on every node meaning, like if you see here, kubelet, this is the Kubernetes agent, meaning your master node will give the instructions to the worker node, right? Master node will communicate with the kubelet to give any instructions or to execute or to deploy some containers here. Means the first component with which master node will communicate on the worker nodes is this kubelet. Hence, it's called the Kubernetes agent running on the worker node. So actually this arrow should be here. Like master will be sending instructions or communicating with the kubelet in particular, right? So that's how it gives the instructions. That's a kubelet. Third component is the kube proxy. Kube proxy is nothing but the network brains of the cluster. Network brains of the cluster, meaning like all the networking, all the like let's say the communication would be taken care by kube proxy, means the communication between the containers on one node to another node, or else communication between containers on the same node, or accessing or exposing the application to the external world. All of this connection or networking would be taken care by kube proxy component. So those are the first three components. Is it clear with the first three components, everyone? So if first three components are clear, let me talk about the next most important component called pod. What is this pod? Pod is having three containers, here one container, here two container. What is a pod actually? Pod is nothing but the basic or the fundamental unit of deployment in a Kubernetes cluster. Means in a Kubernetes cluster, you will never see container like this. What does it mean? You will see container always wrapped around with a layer called pod. Pod is like a layer over the container, or else pod is like a home for the container, or else container lives inside the pod. It's like a living environment for the pod. It's like a wrapper. You can imagine container as a chocolate and pod is like a wrapper around the chocolate, right? So that's a pod. Always container exists inside the pod. In Kubernetes cluster, you will never say, okay, you deploy the container. Until now, I just said that because we did not learn the pod concept. Now, we will never say deploy container. You deploy the pods. Pod is the basic or the fundamental unit of deployment, meaning you deploy the pods, you scale the pods, you delete the pods. You basically deal with the pod, not with the container, right? So being said that it's like a living environment for container, every pod will have some IP address and some network assigned, right? Container living in it will be accessed using the same IP and the same network. Means it will share a same pod network and the pod IP. So that's how it works. Means when you scale the pod, let's say, okay, I want to run a container from Nginx image. Let's say Nginx is the image and you want to run the container. Yes, you will create a pod which will have a container which is running Nginx. If you want to scale it, means it will create another pod and it will run Nginx here. I mean, it will run a container which is coming from Nginx. That's how you scale. It's not that you scale the containers inside the pod. This is not correct. Am I making sense? This is not correct. Then how do you scale it?
Creating a pod.
This is how you scale it, right? That's the correct way to scale it. So every container will have a layer of pod and you scale the pods, you delete the pods, you deploy the pods. The basic, the general or the best practice is one container per pod. Scaling means another pod will be created with the same configuration, means same container within it. That's how you scale. Then what is this use case? Is it not scaling? This one, pod one. No, this is not scaling. Pod can have multiple containers, but those are not replicas. It could be like this is coming from Nginx. Container 2 might be coming from some other service, some log service running. A container might be running some other service. So there are different, those are different containers from different images. That is possible, but not when you scale, it would create another pod with a similar container configuration. Am I clear?
Yes.
Right. So why should you have containers with different configurations? That's a different story. Maybe if you want to share data And let's say Nginx is running, if you want to collect those logs and share it to a volume outside, you may use some other containers like helping containers called sidecar containers and all. That's a rare use case, but you got the difference between scaling and a pod with the different containers, right? Everyone, is this point clear? Thanks, Rohit, for confirming. So those are the different components you have. First one is Docker, kubelet, kubeproxy, and pod. Those are the different components in a worker node. Yes, this is clear. Let me move to the components in the master node. Master node is called the control plane because that's a one which drives the entire cluster. So control plane is having different components like this. API server. Okay, first component is the API server, scheduler, controller manager, HCP. These are the different components. We'll talk about these components, but before that, like I said, master node is called the control plane of the entire cluster. It means by default, your master node will not run any pods, unlike in the Swarm cluster. In Swarm cluster, if you remember, master can take the load by default, right? If you don't want it, we drain the master so that it wouldn't take any load. That's the best practice. Here in Kubernetes, by default, master would be not taking any load. It will not take any containers. It's a dedicated cluster, it's a dedicated node to manage the entire cluster. And the first component is API server. API server is the core component of the cluster. Core component of the cluster or the major component, meaning it's a decision maker. Meaning, see here, you may, like I said, you will be writing a manifest file, right? Manifest file is nothing but you write the deployment configurations and all. That's called Kubernetes manifest file. You write it in JSON and YAML. Here we prefer YAML. And you run that YAML file, right? That's what is CLI. From CLI, you can run it. Kubernetes has got GUI also, which is very rarely used, very less used. Whatever ways you want, you will apply the YAML, right? Once you apply the YAML, that is fed to the API server. API server is the component which will validate your manifest file, which will understand your manifest file. And if it validates it to be correct, then API server will be applying, or else means once API server will validate your input, then it would interact with other component called scheduler. It will also interact with other component called controller manager, and then schedule it on the worker nodes. Means let's say, okay, your manifest file says 4 pods are needed. If API server validates it, it will connect with the scheduler. Scheduler, as the name says, it is the one which schedules the pods onto the worker nodes. It is the one which take care of scheduling, like which pod should be started on which node at what time. This way it will schedule, right? So API server will interact with scheduler. Scheduler will send instructions to the kubelet, like we learned some time back. It will give instructions to the kubelet. Kubelet is the one which starts the pod on the worker node, right? Also, at the same time, API server would also interact with the controller manager. What is a controller manager? Controller manager is the name, as the name says, it's nothing but the controller of controllers. What are those controllers? Actually, we have different controllers like node controller, pod controller, replica controller, endpoint controller, and so on. Basically, controller is nothing but this controller manager is like a watchdog, which will watch the entire cluster. It would run some unending watch loops. Unending means non-terminating watch loops to check the actual state of the cluster. Actual state means what is present on the cluster with the expected state of the cluster. Where is expected state? Expected state is defined or in the manifest file, isn't it? We define the expected state like, okay, we need 4 pods. Okay, this is the expected state or the desired state. So it is present in the manifest file. Actually, there are, let's say, only 3 in the cluster. So this controller manager will keep on running some watch loops, non-terminating, unending watch loops, and compares actual state with expected state, which is defined in the manifest file. And if there is any difference, right, it will again inform the scheduler. Okay, you should start a pod. Then scheduler will start a pod on the one of the worker nodes. It will decide, scheduler will decide on which node it should start, depending, checking upon the resources and health of the node. It will check the resources of the available resources of the node and health of the nodes, and accordingly, it will schedule the pod on the available worker nodes. Understood the flow? API server, you will feed the input to the API server. API server will validate that, right? The given input, it will validate it, and accordingly, it will connect with the scheduler and controller manager, and it will get the information from the controller manager about the actual state and expected state, and accordingly, scheduler will start the pods on the worker nodes. Is this much clear, all of you? How those three components work? Any questions?
This control panel is there, right? So how, so that will be, we will be installing that one or how it is?
We will install those components. Control plane is nothing but master. Master is called as control plane. Those components, we have to set up the cluster with those components. Once you set up the cluster, this is how master node will have, and these are the components worker node will have, and that's how they work. That's the functionality of each component.
Control manager just for checking the configuration or to bring up the pod?
It will just check the configuration. It will compare actual state, virtual state, and it will send that information to scheduler. Scheduler is the one which will talk to the API kubelet on the worker node, and it will start the pods.
Yeah.
Any more questions? So this is how these three components work. Now let's talk about the HCD. HCD is like a memory of the cluster. We consider API server as a brain of the cluster, right? HCD is called memory of the cluster. Means all the cluster configurations are stored here. Cluster configuration means details of the worker nodes, detail of the master node. And we are talking about controller manager will compare the actual state with the virtual expected state, right? How it will get the actual state, how it will get the expected state from HCD only. Also, scheduler will decide on which node it should deploy. How does it know the resources available on each worker node? How does it know the health of the worker node? Again, it will get all this information from HCD. HCD is like a memory of the cluster. It will store all the cluster configuration in the form of key valued pairs. Understood? Is this much clear? Key valued pairs, it's like a NoSQL database where data is stored in the form of key valued pairs. That's how those four components work. HCD is a very important component because all the cluster configuration is stored here. Any questions from anyone?
State of the cluster where it will store or XCD or control manager?
HCD. State is stored in HCD only. All these components will get all that information by connecting to HCD. Scheduler will get it from HCD, controller manager, APS or everything will get the information from HCD. Any more questions? Is it clear?
And one more question. If we have the two control plane, that time also the control manager will take the responsibility of the cluster, right?
Control plane is nothing but master node is called control plane. Master node will have all these 4 components. Another name for master node is control plane because it manages the entire cluster. Is that your question?
No, actually my question is, if we have the multiple control plane, yeah, how it will be act?
Okay, there will be multiple control planes, obviously, multiple masters definitely in real time for again for high availability of the master. Right? HCD will
Yes.
be distributed across the multiple control planes. It will be a distributed storage for all the control planes. Actually, it's a cluster configuration. Even all the 4 master details would be saved here, including the worker node details. It's distributed across the cluster. Means it's shared across the master nodes.
Okay.
So if we are good with this, let us go for the setup.